Hello and welcome back to another GCSE AQA physics revision video. Today we'll be talking about conduction in P1 1.4. So this is just going to be a short video on conduction and what it is. So conduction, there are two types of conduction basically: conduction of electricity, which we won't look at, and conduction of heat energy. And that is what we're going to look at today. So before we start off, I would just like you to pause the video and write down what you think conduction means. Actually, that's just a bit too simple, so I mean you might not get to work from that. So I'm just going to I'm going to give an example of how here you have a saucepan and the oil is at the bottom. You have a frying pan and you're cooking some sausages, and the oil, so that's the sausage. Then you're cooking some oil and the fire is here. So conduction is happening here, but what is it? Well, I want you to just pause the video, write down what you think conduction is. It's to do with heat and how it transfers, because last time we did about how it transfers through radiation. Now we're doing conduction. So how do you think, what do you think conduction is? Pause the video in 3, 2, 1. Okay, I'm assuming you've paused the video, you've written down what you think conduction means. So basically we're going to move on to the definition. So here we can see the fire is actually, I think it would be a better diagram if I draw the fire red for easier reference. I mean, yes, you get blue flames with hotter flames, but just for easy understanding, the flame's red. Conduction is basically the transfer of energy through materials, such as, so say you have the fire here, it's heating the what I guess it would be aluminium or steel pan, and that the metal heats up because of the heat energy from the flame, and it conducts heat energy to the oil, because I'll explain how it gets conducted, which way it goes, but basically conduction is the transfer of energy through materials, mainly solids, but there are some liquids and gases, but they're poor conductors, and we'll explain why soon. So basically you need to know that conduction works like this. So say we have, I'm just going to draw a quick diagram here. So you have two boxes. Sorry about this. Just trying to. So you have two boxes, and one of them is fairly hot. It's red. The other one is fairly cool. It's quite cold. So conduction is actually happening right now. Why? Well, there's something called law of thermodynamics, and there's many laws. There's like around 4 or 5. I'm not too sure at the moment, but there's laws of thermodynamics, and what it is about is it's about how energy is transferred, and particularly heat energy as well. Basically, it says that in simple terms, it would say it means that heat will always transfer from the warmer object to the cooler object. So here, the energy from this block of heat, I guess you can say, this block of wood, if you can see that, this block of wood is quite hot for some reason, and it is being and the energy is now conducted through here to the other block, which is cooler. So eventually the blocks the temperature of both blocks would even out to the point that they're both the same temperature maybe, and that means that there's no difference in temperature, so energy won't be conducted between them anymore. So that's how conduction works. You need something to conduct. Energy from the warmer object goes towards is transferred onto the cooler object. I mean, when we touch the cold surfaces, we'd actually feel the cold. it's not that it's not that the object. Say we're coming home from a snowy day and the door handle, and we have no gloves. The door handle is quite cold, and we touch it. Basically, that means well, our hand will be cold, and basically, sorry about that. Sorry about the noise in the background. Actually, yeah, terribly sorry about the background disturbances. Someone just came in. But basically, as I was saying, when you touch a handle, so you're on a cold day, you're without gloves, and you touch it like door handle, it would be cold. You would feel it's cold, but it's not you don't actually feel the door handle's cold. What is actually happening is because of the like massive difference in temperature between your hand, which is warm because we're warm-blooded, um, and the handle, there's a massive temperature difference. Um, Energy is actually being conducted towards the handle, which is why we feel the cold, because we're losing heat energy in our hands, sorry. So that's why we feel cold, basically, because we're losing heat energy. So, if you want me to write this down, basically, conduction, I can't type, happens through materials, mainly solids. Mainly solids. Just move that across here. And then we could say, in conduction, heat transfers from the cooler object. Oh my god. Sorry, the warmer object. Might have confused some of you there. Sorry, I meant the warmer object to the cooler object. So basically, that's all there is. But obviously, different materials are better conductors, better insulators. I mean, you wouldn't get like I don't know, wood as a frying pan because it doesn't conduct heat very well. And so, if something is good at transferring energy through conduction, we call them conductors. Conductors. And basically they are. Conductors are, like, against substances, I guess you can say, which conducts or transfers heat through conduction, which we know the definition of, easily, or well. So conductors are substances which transfers heat through conduction well. The opposite of that is an insulator. And you may have heard of conductors and insulators in electricity terms, maybe, but yes, they are using electricity terms, and we'll explain that later on in later lessons. But there's also they're also talked about in heat, and an insulator is a substance basically which does not transfer. Is a substance which does not transfer heat through conduction well. So, what makes a good conductor and what makes a good insulator? Well, one of them would be you need one of the main ones that the example actually really wants you to know is basically free electrons. As we have said in chemistry, if you don't watch chemistry, electrons are subatomic particles basically, and so all things have well. I'm going to give you an example basically. Metals. Metals are great conductors of electricity. I mean, no, great conductors of heat. Sorry. So I can draw like I don't know, a bar of iron bar. I don't know. A copper bar. It's a good conductor because one is dense. denser matter have denser materials like metals. They're usually quite dense. Um, they have like tightly packed together atoms, and that means that when one part of the atom is heated, it will gain energy, as we have said in the kinetic theories. It will gain energy and knock around with other atoms and passing on the heat energy, and eventually the entire bar of copper would get heated up. So we could like say, at first you would put heat through here, and then the individual atoms here, they would start getting energy because of the heat, and they would start vibrating more, and in doing so they would knock onto other atoms and transfer that energy, and eventually this repeats until the whole bar is the same temperature. But it's not just density, it's also to do with free electrons, that I've said. Free electrons are vital in what makes metals so such good conductors, because free electrons basically electrons that are not attached to any atoms, so they have tons of energy, meaning when they're heated they will just basically whiz around everywhere, I guess you can say, and transfer heat by doing so, and that's a much more efficient way because they can move quicker with a lot more energy, which is why metals are such good conductors. Whereas non-metals, they don't have free electrons, because most good conductors, they are mainly metals basically, because they have free electrons. Whereas non-metals, they are usually poor conductors because they have no free electrons. So we've gone through an example of a conductor, but what is an example of an insulator? Well, I guess if you want to take notes, you can just come back. But I'm gonna clear the. I am going to clear the screen now. But basically, I'm gonna clear the screen for some space. Okay, sorry about that. So we're gonna go through examples of good conductors. Conductors with my poor handwriting, because I'm a mouse. I'm a mouse. I'm a mouse. I'm a mouse. Right. So insulators. So there aren't really too many good conductors. Metals are the main ones you need to know about. So I'll just go with metals for now. Unless unless you need to know more, I would mention so in future videos. But metals are the main ones. So, one of the uses of good conductors like metals is like cooking, because in frying pans or like saucepans you would need it to heat up quickly in order to cook quickly, and yeah. So yeah, so this thing cooking. With my poor handwriting again. Sorry for that. I don't know why I did the G so big. So yeah, so insulators. My focus now is on insulators, and examples of good insulators include wool, fiberglass, which these are the ones, the example ones you didn't know about as well. Fiber. Oh god, I wrote that so bad. That was terrible. Fiberglass. Fibreglass. And also wood. And now, what makes most, particularly the wood and wool, such good insulators is that they have air trapped inside them, and air is a really good insulator. Because, well, we use it as a way to trap heat. I mean, say in the Antarctic, polar bears would have thick fur, and what it does is it traps air inside, between the fur, and air is a good insulator, which means it stops heat from getting out. Because remember, the heat will, because the polar bear is warmer than the environment, the heat is trying to escape, but it's not being allowed to do so as efficiently because of the air. So we've got wool and fiberglass and wood, and that's really all there is for this video. If you don't understand anything, be sure to ask me. If there's a particular thing your physics teacher has taught you that you don't really understand about a certain topic or I haven't covered, and you still want to know more about it, tell me in the comments section below. Because I am working from a revision book, unfortunately, because I ain't got a textbook. So I might not cover everything. So if you need something covered, tell me in the comment section below, and I'll happily do so. And also any questions and such. So the main points today were conductors, what they are, which you should know by now. What conduction is, as well. Insulators, what they are, examples, and why they're good insulator. What makes a good insulator? What makes a good conductor? As well as what direction heat energy transfers, if you know. So yeah, that's all this video will be on. I try to keep it actually quite short, but it turned out quite long, unfortunately. But I hope you found this video useful. Leave a like, comment, subscribe for more videos such as this, and I'll see you guys later.